Here are final exam scores actually for last semester, for the fall of 2010. So here they are. They're not in any kind of order or anything. Before we start summarizing this, I want you to notice the blank lines. What those represent are people that were originally enrolled on Blackboard at the beginning of the semester, but didn't take the final exam. So you can kind of look through the scores there, and you can also see that there were some people that started but didn't finish the course. So like I just said there. But actually I went back and looked. Most of the students that didn't take the final exam that were enrolled never attended a class, or at the very least they never turned in one homework assignment and did not take the first test. I guess they either switched to another class or came in, took one look at me and said, "There's no way I'm doing this." There were originally 105, 87 of them took the final exam. Some proportion of those, I really think that the number of people that dropped because of a poor grade was probably somewhere in the maybe 5 to 7, maybe 8. Most of those that dropped were, except for other reasons. In fact, I did have a couple of people who dropped for medical reasons as well. Here are those numbers in order. Usually you would start from the bottom and go up, but since these are grades, I started at the top grade, was 98 on the final exam, and it went down to 34. So anyway, I'm going to organize those, or I did organize those, into a frequency distribution that just classes everybody or groups everybody into different groups and then counts the frequency in each. So if you went through and counted on there, you would have found that 18 students were in the 90s, greater than or equal to 90, but less than. Usually I would on that 100, since it's in the A's, say greater than or equal to 90, up to and including 100. But the rest of them, greater than or 80, but less than 90, there were 25. 18 in the 70s, 15 in the 60s, and then 6, 3, and 2 in the 30s, 40s, and 50s. So you can see, at least as the final exam went, quite a few A's and quite a few B's, some C's, and then lower and lower, especially. I'm glad not too many failed the test. I guess some did. The relative frequency then would be the number in each group. There were 87. So I had 18 in the first group. Divide that by the 87, and you should get 0.21. These are the percentage that were in each of the groups. On the final exam, 21% got an A, 29% B, 21% C, and so on. So this is the relative frequency distribution of the values that were in the previous chart. Continuing on now, that was just getting some things into a table form, frequency distribution. Now we're going to make a graph of that frequency distribution, and a graph of a frequency distribution is called a histogram. But anyway, you can see that there were 25 people who scored B. About 18 were in each of these two groups, and so on. You can read that across there. So we have greater than or equal to 30 but less than 40, greater than or equal to 40 but less than 50, greater than or equal to 50 but less than 60, and so on. It's just a graph of the distribution. I also used it here to compute percents or proportions. This one says percent. Proportion would be the same thing, or relative frequency, just put decimals in there. It would be 0, 0.1, 0.2, and 0.3. I can see that a little less than 30% scored B, reading this across here. A little more than 20% in each of these two categories, A and C, and so on. So one of the reasons you want to have percents or proportions here is so you can compare. If you had more than 2 histograms, you can compare those. If I had, the grades this time out of 87 students, and I put all the grades, and let's say in another semester I had 200 students, the one with 200 students, everything would be higher than everything in the one with 87, so you really couldn't directly compare the heights of the two graphs. But if I had constructed both of those, and instead of having absolute frequencies, I had percents or proportions, then I could compare the two graphs. I would have this, both of them would be in terms of the percentage of A's or proportion of A's, B's, C's, and so on. A few things you ought to notice about any histogram that you have are the center. The center's around 80. Might be a little less than that, but that's around the middle of the distribution. The modal class, the class that has the highest frequency, is the class 80 to 90. So B was the most common grade on the final exam. the range from the highest part of the maximum value in the distribution to the lowest. So it's about 70. And most of the data are between 60 and 100. So we had those values below 60. The range is 30, but most of the values are between about 60 and 100. So at least most of the people passed the final. Also, you can see that this distribution tails down to the left. So that means it's a skewed distribution, and it skews to the left. There are a lot more scores at the upper end than there are at the lower end. Of course, the one we just had was something like this, skewed to the left. Of course, if we had a graph that looked like this, that one is skewed to the right. And then sometimes we'll have a distribution that looks something like this, or something that follows something that looks sort of like a bell curve. It doesn't have to be exactly a bell curve, but it has that mound shape to it. As you'll see when we do some things later in the class, I mean, for now, I'll just be able to recognize them, but the shape of the distribution is one of the things that's going to affect the sample size needed when we do a study. Though there are other criteria, one of the criteria depends on some characteristics of the distribution, like the histogram, like whether or not you have a bell curve. In fact, I'll just say, generally speaking, if you have bell-shaped data, you can have smaller sample sizes. Where if you have skewed data, then you'll need a little bit larger sample, get a valid measure for the mean and the standard deviation, or at least a measure that we can use for what's called hypothesis testing and interval estimation or statistical inference.